Hello, my name is Seth Gnesin, and I am presenting on my summer 2020 Monroe Research Program, where I worked with Professor Jonathan Frey from the Applied Science Department on model rocket trajectories and how to keep model rockets flying vertically. Now, the problem is model rockets don't fly vertically. They tilt, they roll, they move because of wind. And the goal was, how do we make them fly vertically? Well, we were going to apply some wings, control surfaces, is what they're called, and use some feedback to angle these surfaces relative to the rocket in order to push the rocket back to vertical. So from a hardware perspective, I needed a rocket. I used the Lodestar because I didn't want my electronics to go shooting out the front when the parachute deployed. I used 4 clip delta wings, that's this wing shape, from Apogee rockets. I used a Adafruit M0 logger in order to record the data. And then I used a proto wing for extra connections. I used 2 sensors. I used an accelerometer and I used a barometric altimeter. I used 4 motors, sub-micro servos, which had enough torque to move the wings, but are also really light. And then I used 2 very lightweight batteries and a current booster in order to make sure the motors could turn. Now, the goal was take the data, record both the altitude and the acceleration data for later calculations, but also take the acceleration data and find the error from the vertical. Then use a feedback control to calculate what to do with the wings in order to change them in order to fix that error, and move the servos to move the wings. Repeat. Now, this is the code implementation for that. Essentially, it says the same thing as the flowchart. The results were, as you can see in the video, not great. The rocket flies straight up, it turns and it corrects itself, and then it crashes to the ground. And the reason why it crashes to the ground is because I didn't account for the fact that both the rocket was top heavy now with all the electronics I added, and also very asymmetric. And this caused it to be too much for the rocket to compensate for. However, we have a visual confirmation when the rocket goes straight up that, yes, this concept works. These control wings can help compensate for it if the rocket was better weighted and also had a stronger engine in order to compensate for this. Separately, data was not logged to the SD card because of an error in coding. And unfortunately, the rocket could only fly once. As it can be seen, the rocket just crashed. However, visual confirmation does show proof of concept. Thank you.